Welcome to the 5.3 mixed review video for our notes. This is Miss Bryant. We're going to be comparing when we add or subtract polynomials with when we are multiplying polynomials. So the big thing we have to remember in this case is when we add or subtract, we're looking for those like terms and we do not change the exponents. But when we're multiplying, we want to add the exponents of those powers that have like bases. So the biggest thing between the two is those like terms and then adding those exponents. So for this first question, we're going to look the difference between adding and multiplying. When I add, I have a 4x squared plus a 10x squared. Since they both have an x squared, they are like, and I can add them, so it would be a 14x squared as the final answer. You don't change anything about the x squared, you're just adding those coefficients. When we multiply, I'm multiplying 4x squared times 10x squared, but I multiply 4 times 10 times x squared times x squared. This would leave me with a 40x to the fourth because I add these exponents of a 2 plus 2, which to give me 4 as my final answer. For question 2, we are going to be subtracting a 3a squared minus 5a squared. Since they both are an a squared, I can go ahead and subtract. 3 minus 5 would give me a negative 2a squared. When we multiply, I'm multiplying my coefficients. 3 times 5, 15. And now I have to go and add those exponents. So I have a 2 plus 2, which leaves me with an a to the fourth. For question 3, we are looking at negative 3b plus 9b squared. This b that doesn't have an exponent actually has an invisible 1 hanging over it. B to the first and b to the second are not the same, so my final answer is a negative 3b plus 9b squared because they are not like terms. You can rewrite this as standard form, being 9b squared minus 3b. We did not change the value of our polynomial at all. Minus 3b times a 9b squared for when we multiply would be negative 3 times 9 times b squared. So negative 3 times 9 is a negative 27, and this b to the first times b squared is a b to the third for my final answer. Now coming back up to the top for question 4, we're going to be looking at subtraction of a 2 minus a polynomial. When I have that constant in front and I'm subtracting a polynomial, we need to distribute this negative to each term in the polynomial. We can rewrite this as 2 minus x squared minus 3x plus 7, and now we have to look for those like terms. So I have a 2 and a 7 as my like terms, and this negative x squared and negative 3x, I don't have anything else to combine them with. So my final answer will be a negative x squared minus 3x, and 2 plus 7 is a positive 9 as my final answer. Now for when I go to multiply, instead of distributing a negative, I'm distributing this 2. 2 times x squared, 2 times a 3x, and 2 times a negative 7. So my final answer would be 2x squared plus, now I'm doing 2 times 3x, which is 6x, and 2 times a negative 7, which is minus 14. For number 5, when we add these two binomials, I can rewrite this as x plus 4 plus x minus 9. The distribution of this positive 1 does not phase any of the signs that are originally in that second polynomial. Now we're just going to look for those like terms. I have an x and an x, and I have a positive 4 and a minus 9. So my final answer is going to be 2x minus 5. When I multiply, I'm going to be doing the box method. So x and plus 4, and I have an x and a minus 9. So x times x is x squared, x times a minus 9. Now continuing with my box, I have x times x for x squared, a minus 9 times an x for a negative 9x. Now I have 4 times x to give me 4x, and 4 times negative 9 to give me a minus 36. My final answer, when I write it all out, is going to be an x squared. Now let me look for those like terms. Here I have just a minus 9x and a 4x. So I'm going to combine those and get a minus 5x, and then a minus 36 is left. For question 6, I'm going to be adding m minus 3 plus an m squared plus 5m minus 6. Here we don't have to worry about anything with distribution because again it's that positive 1 that would go to each term and that does not change anything. So m minus 3 plus m squared plus 5m minus 6. We're looking for those like terms. I don't have any other m squareds, just 1. I do have 2 m's. I have 1m and plus 5m. If I wanted to start rewriting my final answer, I'd have m squared plus 6m, since this is a hidden 1 in front of my m. And then when I combine these constants, a minus 6 and a minus 3, I'll have a minus 9 as my final answer. When we go to multiply, we want to make sure that we do that box method. I'm going to start down here. So we have m squared, 5m, and minus 6. And on the side, we're going to have m and minus 3. So when I multiply m times m squared, all I do is add those exponents for an m cubed. M times 5m is 5m squared. And negative 6 times m is negative 6m. Negative 3 times m squared, now that I'm on that second row, is going to be a negative 3m squared. Negative 3 times a 5m gives you 15m. And negative 3 times negative 6 leaves you with a positive 18. Now we have to go ahead and look for those like terms. My like terms are going to be this 5m squared with the negative 3m squared, the 15m, and the negative 6m. So to write my final answer, I have an m cubed plus 2m squared, because a 5m squared plus a minus 3m squared is going to give me positive 2. And now when I combine a 15m minus a 6m, I'll get a positive 11m plus 18. Thank you for watching this video.